Okay, this is classwork video 11.8. I'm going to have you take the handouts I'm giving you, copy all the work I'm showing you, and then write down the 5 words that show me that you listen. So we're looking at domain and range, and then next topic will be interval notation. But today, domain and range with thrown in arrows. So here we go. Looking at domain and range for data given to you. This domain, if I could have you write that. Domain is measured from left to that right direction. Where you go from left, where the left end part of the data, the furthest left, where that boundary line slices through that X number to get that, all the way to the right part of your data. And then again, you look at that X number where that data slices through. That's where the boundary line is from left to right for my domain. But range is not measured left to right. Range is measured from bottom to top. I'm going to have you write that. Range. Range is measured from bottom up to top. Bottom to top is range. So that is the bottommost boundary where it slices through that on the y-axis up to the top part of that boundary where that slices through, where that data is going up from bottom to top, where it slices through. That's where I'm getting these numbers that I'm about to write down. So here we go. Domain measured left to right, where it looks at and slices through the x-axis. So it looks like this first boundary is from -6. Because there's a dot right here, I'm going to write that square bracket. It's really important that you write that square, not rounded, and I can see it's clearly square. From -6, comma 2, 7, no dot over here. I'm going to have you write that as a rounded, clearly rounded. And then that is called set notation. If I want to do interval notation, I use those same numbers, but I use inequalities, and then they match those brackets. If it's a square bracket, inequality has a little line. Domain always X, and then that bracket being rounded, the inequality is missing 2, 7. That's interval notation. Range from bottom to top. Looks like it's slicing through right here. If I can do that in red. Through 1 on the y-axis. Because there's no dot there, I'm going to do a rounded on 1 up to 7, and a little change now. We're going to consider this a square part of my data because there's no break in the data right here. It's continuous right here. So they're telling me no break in the data. Make that continuous. It's like if there was a dot up there. So just know that. The only place you got to worry about a dot or no dot are the ends. So here we go. That's going to be 1 up to square bracket 7. Writing interval notation from 1 less than, put a y right there because you're representing y values, less than or equal to 7. First word is fish. Fish. Next one. Looking at domain. Domain from left to right, worrying only about the ends. Looking at this end, no dot right here. Looking at this, I got a dot. This we're going to consider a dot up here now, so just know, don't worry about that spot right there. That's continuous right there. That's a dot. So my domain measured left to right goes from rounded -5, comma 2, 4 on the x-axis, square. And again, I got those boundaries by looking at my data from left to right, where it goes through the x-axis. Those are the numbers. That's where I got them. That's my domain. My range measured from bottom to top, where it slices through the y-axis from -2 up here to 6. So that would be both square up to 6 square. That's set notation. If I wanted interval notation, use those same numbers, but inequalities with x in the middle, and then inequalities match those brackets. So -5 less than x less than or equal to 4. This one is -2. Put y right there. All right, next word is dog. Dog. All right, let's keep rolling, getting a little harder. This one, no dots. But again, no, this is a dot up here. So again, the way I'm teaching that now. So here we go, my domain. Domain measured left to right goes from rounded -8 to 3 rounded. Interval from -8 less than x to less than 3. That is my domain. My range measured from bottom to top looks like rounded 2 on the y-axis there up to 8 rounded. Again, I'm getting that by looking at where those are slicing through the y-axis. Range is usually the hardest. Domain is usually a little bit easier for people. And then my interval notation from 2 less than y less than 8. All right, new topic. Putting an arrow at the end of it represents that data going on forever, ever and ever. And forever, we call that going on to infinity. It's going on forever. It's never stopping. That's what that arrow means. That means this is really still going as we speak, going forever. That's the new topic today. So if I did this domain, my domain, left spot, I have a square bracket from -4, but that arrow going off to the right, and I know going down is tempting to write the negative infinity symbol because it looks like it's going down, but remember, anything measured left to right, positive infinity, and I put a rounded bracket around that. And then that interval notation would be -4 less than or equal to x less than never equal to infinity. Can't be equal to infinity. It's going on forever. My range measured from bottom to top. This one's never bottoming out. So I do put a rounded negative infinity up to 6, and that's going to be a square. And again, these are difficult. We'll practice. From negative infinity, there's no bottom to it, up to 6 on the y-axis. And then if I did that interval notation, negative infinity, less than, put y there, less than or equal to 6. Next word is crab. Crab. Let's keep going. All right, last set, I believe. Is it? Oh, no, 2 more. Let's crank them out. So this one, my domain measured left to right goes from -5 rounded. Arrow going up would be positive infinity. If I did that interval, -5 less than x less than infinity. My range measured from bottom to top looks like from square bracket 3 on the y-axis going up positive infinity. That would be 3 less than or equal to y less than infinity right there, positive. Next one, domain measured left to right. Looks like square bracket -7, arrow going up, positive infinity rounded. Interval notation, x in the middle, never equal to infinity. My range measured from bottom to top looks like from square bracket -2 up to infinity rounded. And then y in the middle. All right, next set. Last one, here we go. Domain measured left to right. This arrow is shooting off to the left. So I do a rounded negative infinity 2 square bracket, nope, open bracket 9 rounded, no dot up here. If I did that interval, negative infinity less than 9. Doing my range, measure from bottom to top, looks like 1 square bracket's got a bottom to it. Going up, and I know it's tempting to put negative infinity, but anything measured bottom to top going up, positive infinity, rounded. Put that 1, y. Remember, you can never be equal to infinity. All right, next one, last one. Domain measured left to right. This is going off to the left. That's why I write that rounded negative infinity 2, 9 square bracket on this one. Interval notation. Next word is pig. Pig. Almost done. Negative infinity less than x less than or equal to 9. For the range goes from rounded negative infinity. It's going down, down, down. No bottom to it. Negative infinity down. Anything measured bottom to top going down, negative. Anything measured left to right going left, negative. So this would be negative infinity to 9 square bracket. And then if I wrote that interval, all right, and I'm just gonna skim through to make sure I got them right. Negative infinity 9, negative infinity to 2. Looks like I got a 2 right there. Let me fix that. Thought I was going a little too fast. That would be a 2 right there, positive 2. All right, looking at my others, negative infinity to 9, 1, 2, positive infinity. I like it. Going back to these, just double checking my answers. All right, looks good. Last word is ray. Ray. Talk to you in a bit. Good luck gutting this out. First one to throw me a shaka or a hang loose, give you a little extra credit.